Hi, in this video I will show you how I replaced a Generation 2 wheel bearing assembly using a standard wheel bearing press kit and my homemade tools.
For the majority of DIY people, it is better to replace this type of wheel bearing with a specialized toolkit. A portable Gen 2 wheel bearing toolkit is easy to use, but it is expensive. Renting one can be a good option. A proper hydraulic press with metal plates, sleeves and blocks can be used to do the work. When installing a Gen 2 wheel bearing, it is crucial to apply the compression force on the outer race when the bearing is inserted in the housing. Before buying any parts, I took time to drive my vehicle and validate that the noise was coming from a front wheel bearing. So, when I was driving and turning the front wheels in the right direction, the noise was increasing. Usually, it means that the front left wheel bearing could be defective. The next day, I parked the vehicle in my garage and I engaged the parking brakes. I also loosened the front wheel lug nuts before jacking up the vehicle. I used 2 floor jacks, 2 jack stands, and 4 wheel chucks to prevent the vehicle from moving. Next, I spun the front wheels by hand to hear a distinctive noise. It was still not obvious to isolate the noise. So, to eliminate the parasitic noises, I removed the brake parts. I began by removing the parts on the right side. The guide pin plugs, the guide pins, the spring clip, the floating caliper, and the outer brake pad. Usually, I use short bungee cords to hold the floating calipers. After, I undid these 2 bolts to remove the caliper bracket. At last, I removed the rotor. I also removed the same parts on the left side. I was able to feel a small vibration coming from the bearing on the left side. This was the confirmation I needed, so I undid the center bolt of the drive shaft. I kept the center bolt partially unscrewed to be able to retract the drive shaft from the bearing assembly. Luckily, the shaft was not seized, then unscrewed the bolt completely. To remove the dust shield, I undid 3 small bolts. The wheel speed sensor was stuck in the cavity, so I disconnected the harness connector. Next, I unscrewed the nut holding the outer tie rod end to the steering knuckle. I used the nut to unseize the ball stud. To prevent the ball joint stud from spinning, I applied some compression force from under the ball joint with a common scissor jack. Then unscrewed the nut with a wrench. When it is not too tight, a ratcheting wrench can be used to unscrew the nut faster. At one point, the threads were rusty, so I sprayed some penetrating fluid and I loosened the nut with a wrench. Later, when the nut was undone, I removed the jack. The shape of the ball joint separator must fit with the ball joint model. With my tool, I had no problem to extract the ball joint from the knuckle. I used my control arm tool to move the lower control arm down. I checked the ball joint and it was still in good condition. I used 2 small bungee cords to hold the CV joint when the shaft was out of the bearing. My small impact tool was efficient to undo the bolt from the knuckle strut mount. Often, the base of this kind of strut is seized in the strut mount. To loosen the strut mount, different prying tools can be utilized. Next, I used the big hammer to separate the knuckle from the strut. When the assembly was on the workbench, I had no problem to distinguish the vibration coming from the bearing. I removed some dirt around the base of the wheel speed sensor and I sprayed some penetrating fluid inside the cavity. Here, I used small pliers to wiggle and extract the sensor. This is the view of the cavity from behind the knuckle. And this is the wheel speed sensor. Here, the illustration shows two graphic views of a specific Gen 2 wheel bearing in and out of a steering knuckle. It shows how it is installed in order to remove the bearing from the steering knuckle. A common hydraulic press can also be used with special plates to remove the bearing. To extract the bearing assembly from the knuckle, I secured the assembly in the bench vise. And then I positioned my homemade pulling adapter on the knuckle. I made it years ago to extract a studless Gen 2 wheel bearing assembly. I designed this adapter to be used with a common bearing press kit. To ease the pulling, I applied a coat of grease on the threads. I inserted the puller bushing and it fitted perfectly under the bearing. Soon after, I installed the force screw to extract the hub and bearing assembly. To begin, I used an impact tool to tighten the force screw. Then I continued the work with a big ratchet, because I wanted to know what was the force that was required to extract the bearing. At one point, the 5 studs were interfering with my adapter. So I disassembled the pulling components, I removed the 5 studs, and I completed the pulling without the studs. When the bearing was extracted, I disassembled the bearing pulling parts, and I removed the steering knuckle from the bench vise. This is the old bearing assembly. Before reusing the steering knuckle, I removed the rust from the contact surfaces and I cleaned them up. Next, I positioned the steering knuckle in the bench vise in order to refit the new bearing assembly. This bearing was already covered with a thin coat of lubricant. As far as I know, it's not required to lubricate the outer race of a Gen 2 wheel bearing. However, I kept the lubricant on the outer race to ease the installation. On the other hand, the meeting surface of the bearing housing was clean without lubricant. Normally, a Gen 2 wheel bearing needs a bearing press kit with special parts to insert or extract the bearing from the steering knuckle. I didn't need them because my homemade system is a shim plate holder that fits tightly between the hub flange and the outer race of the bearing. The shim plates transfer the compression force from the hub flange to the outer race. When the nuts are properly tightened, the shim plate holder fits exactly in place. A common Gen 2 wheel bearing press tool uses a clamshell assembly to properly apply a compression force on the outer race of the bearing. The same compression force on the outer race can be obtained with this kind of hydraulic press. These are the parts I put together to press the bearing into the bearing housing. Then I positioned the bearing in front of the steering knuckle. Next I fitted the bushing and the force nut. This is my basic setup. It is different from the commercial kits, but I made it to obtain the same result. I forgot to put some grease between the force nut and the washer plate, so I had to hold the shim plate holder when I was inserting the bearing. Other than that, the work went well. It was also easy to feel when the bearing was properly seated on the inner shoulder. When it was done, I removed the press tool components and my shim plate holder. I checked the bearing. It was spinning properly. Here you can see that the other side of the race was resting on the inner shoulder. The small cavity was clean, so I refitted the wheel speed sensor. This is how it looked on the other side. To make sure the knuckle strut mount would fit easily, I spaced it out again and I checked the spacing with a gauge. Following that, I placed and aligned the knuckle by hand. When it was holding by itself, I used a big hammer to force it in place. Next, I positioned the lower control arm to insert the ball joint stud in the knuckle lower bracket. Refitting the rest of the parts was similar to the reversal or removing them. So I refitted the strut mount bolt, the CV shaft, the ball joint nut, the tie rod end, and the nut. I tightened the wheel speed sensor screw to 7 foot-pounds, and I reconnected the harness connector. I tightened the tie rod end nut to 37 foot-pounds. The steering knuckle strut mount bolt was tightened to 66 foot-pounds. The ball joint nut was tightened to 52 foot-pounds. After, I removed the jack and I fitted the new center bolt on the drive shaft. It is better to tighten the bolt to specs before applying the load of the vehicle on the bearing. I tested the bearing again and it was spinning smoothly. I installed the dust shield and I safely tightened the small bolts. Next, I refitted the rotor and I used 2 lug nuts to hold it in place. Then I installed the caliper bracket. I tightened the 2 retaining bolts to 89 foot-pounds. Before installing the floating caliper, I positioned the outer brake pad in the caliper bracket. When the floating caliper was in place, I tightened the guide pins to 22 foot-pounds. I fitted the end caps and I installed the spring clip. After a basic inspection, I undid the 2 lug nuts to install the wheel. Later, when the 2 wheels were installed, I lowered the front of the vehicle and I tightened the lug nuts to specs.
If you decide to have this kind of wheel bearing replaced at a local auto repair shop, make sure the mechanic uses a compatible toolkit to avoid damaging the bearing.